Zdravstvujte, moje ime je Ivan Čukić. Ja razrobočnik KDE, or at least Sergey wrote something like that on the web page. So KDE is one of the, well, it's the largest free software C++ project in the world. And we love it. And I'm not here because I'm a member of KDE. I'm here because I love to give talks about C++, and usually I talk about functional programming because it's kind of my thing. Sergey told me that there is a nice Qt community inside Nizhny. So I decided not to speak about functional programming, but to speak about something related to Qt. Now, on the web page, it was written that the presentation is QtFuture, which might have confused somebody because some of you might think that I'm going to talk about the future of Qt, which I'm not. The future of Qt is very bright. If you want to listen about it, you can. There are talks from QtCon, so you can listen about it. I'm going to talk about one of the parts of Qt that maybe doesn't really have a future, so let's continue. Okay, first, I usually start my presentations with a few disclaimers. The first one is that you should always write your code readable, as if the person that will read it next or hack on it is a psychopath and he knows where you're living. So if you write bad code, he'll just come to your place and kill you. So try to write readable and understandable code always. The second disclaimer is that the code snippets in the presentation are obviously optimized for the slides. They're not optimized code. So I'm going to omit std namespace. I'm going to omit forwarding references and similar stuff. OK, so what are futures? Usually when you call a function, for example, t value equals function call, the function will be executed, and the result will be stored in the value. Now, the problem is what happens if the function is just some slow computation or you're connecting to a server or stuff. Essentially, until you get the result, your code is blocked, which is definitely not something that we want to have in our programs. So what are the operations that can block input, output? The disks might be slow, the database might be slow. When you're waiting for the user input, it's again slow, the user is slow. And obviously network communication. If you connect to a web server and you want to retrieve a page, it usually takes some time. You can't block your main program until the result is returned. So what we usually do is to create callbacks, or in Qt use signals and slots, or the worst option of all, spin off a thread, do the work in the thread, and then continue when the thread finishes. The problem with all of these is that, for example, calls and callbacks, we have a function, and then we are passing it what is the continuation. When the result appears, what function should be called? And then you get something like this. You have a really simple diagram of what your program should do, but because you have to split your logic into multiple functions, call, callback, call, callback, you usually have a couple of calls that should be asynchronous, and you have to chain them. You get a diagram that looks something like that one on the right side. And it's worth noting that the right diagram doesn't really do the same things, all the things that the left one does. And it's much more complex. So the problem with calls and callbacks is that they make your code really ugly. And this is one of the things that I always show. It's a sculpture by George Hart called Spaghetti Code. And the thing, OK, he's an artist, but he really nailed it. Because as you can see, everything is just jumbled on the top, and in the center you have the event loop, which is clear and pure and beautiful. Just the things that you write around the event loop are just ugly. So instead of designing your code in the way calls, callbacks, or signal slots, you should create functions that don't really return values, but just return a handle that will eventually in the future get a value. So when we write something like future of t, it means that we get a handle that will sometime in the future get a value of type t. Okay? Now, since it's only a handle, you have a couple of options for accessing the value inside. You can call .get. Now, this has a huge problem. Does anybody see the problem if we call .get on a future?
Blocking.
It's blocking. So we essentially, somebody gave us a beautiful asynchronous API, and we decided just to ignore it, not to use the curse word, and call it .get, which makes it just like the previous case most of the times. So if you use the .get, your program will be blocked just as the same as in the previous example where we had a normal function. Instead, we should just tell the handle, when you get a value, you should execute this continuation on the value. So in a pseudocode, it would be something like handler arrow and pass a lambda that handles the result. Now in the Boost Future and STL in one of the future standards, you will have a .then function, a member function, which you can pass a lambda to, and then it will just join. When handler gets a value, it will call the lambda that's specified with the .then. Alternatively, in some of the really future revisions of C++, we will have something called await, although the syntax currently is co_await, which is kind of ugly, so I omitted the co_ part, which will do some magic behind the scenes, some monadic stuff that I'm not going to talk about today. But the idea is the same. When you say await handler, it's essentially the same as just calling handler.then and passing the rest of the function in the .then as a lambda. It just flattens out the layout, so it all ends up pretty. So one of the really nice quotes by John Carmack. Does anybody know who John is? Okay. I guess the younger parts of the audience are oblivious of what Doom is. Okay, so he said that when you have your program, it's the main problem that we have is how to deal with the program state. And that state becomes even more complex when you work with threads and concurrent programs. So essentially, we should always avoid explicitly dealing with mutable state. And the classes that can help us to achieve that, and the classes that model the future concept, are std future, currently really bad class. Boost future, it's a nice class. We have a Folly future, the Facebook library called Folly. It's one of the cleanest implementations of futures. And we have the really problematic child from Qt called QFuture. Now, usually I just explain why I don't want to talk about QFuture because it generally sucks. But this time I'm going to ignore all of the others and just talk about the QFuture. So the history of QFuture, it started as a part of Qt concurrent library. And the idea was if you have collections that you need to process to filter them, map reduce and stuff, you would use Qt concurrent. Functions from Qt concurrent would return a QFuture. And when the future arrives, you get a result of your MapReduce problem. The main use case was the fork join pattern. So you have a large collection. And for example, you have 4 cores on your system. You split the collection into 4 parts. and each part is processed on a separate thread, then it's joined back, and you can use the result. That's why it's called fork join. Now, when Qt 5 was announced, Mark Matz from KDAB proposed that because QFuture could be a really nice thing to model a lot of stuff, that it shouldn't be in Qt concurrent anymore, that it should be moved to Qt core because it's a really, really, really useful class. And people listened to the guy, and QFuture was moved to Qt core. And that's the only thing that happened to QFuture since. Now, the first problem is that it's still meant only for multi-threading. You can do asynchronous computing even without threads. Connecting to a server and receiving the response doesn't need you to spin off a new thread. And QFuture is designed to work only with threads. So it's not really a general class. In Qt 5, we have a lot of things that are executed asynchronously. For example, we can use the meta-object invoke method to invoke a slot or some scriptable member function in a class. And if you use queued invocation, so just queue it, don't immediately execute it and return the result, the documentation says if the invocation is asynchronous, then return value cannot be evaluated, which sucks. It would be much saner if invoke method, when invoked with queued invocation, just returns a future that will contain the result once it's available. The second part is Qt dbus pending reply, which is, dbus is IPC for Linux, available on other platforms as well, but not ubiquitous. Again, Qt dbus pending reply is a container that will at some point contain a value. And it's not called QFuture. And it's not thread-based, etc., etc. Then you have Qt network reply, again, something that will be available in the future. A little bit bigger class than Qt dbus pending reply. And then you have a lot of external libraries that model the same thing because Qt doesn't provide it. So in KDE frameworks, we have a class called kjob, which is, again, something that will return a value once it's available. So what would be really nice if we had in Qt 5 is that we don't really want to care, is it a dbus reply, is it a network reply, is it something else? We just know it's a value that will be available at some point, and the type is T. It would be really nice if it could use QFuture instead of all of the previous classes. And this talk will be after the first ranting part about how QFuture sucks. We are going to see how it can be abused to model other stuff as well. So the first thing, because now, as we said, QFuture is separate from Qt concurrent and it lives in Qt core. How can we create our own QFutures? If you look at a class, you have two constructors. One constructor is the default one. It creates an invalid future. And the other constructor is a copy constructor. So if you use just Qt core, you're able to create only invalid futures and duplicate them how many times you want, and nothing else. Then, obviously, because the API doesn't really fit our use case, you open the documentation, and it says, to start a computation and to get a QFuture, you need to use some of the APIs from Qt concurrent, which is really sad because we separated QFuture from Qt concurrent because it's useful. Unfortunately, you still officially can only create QFutures by using run, filter, or mapped reduced from Qt concurrent. So the next step, how do I get the value? Again, we can call .get, which will block your main thread. And the only useful thing about .get is only and only if you use the fork join pattern. Alternatively, what we said, we want something like .den. In Qt, it's a little bit more verbose than in Boost or Folly. you have to create a QFuture watcher and then connect the signal from it, blah, 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 and define a future. And this is just a boilerplate code that is the same in every program that you will ever write using the QFutures. So we will be trying to make all of these things work much better. Now, a couple of special things about QFuture is that usually when you say future of t, it means a single value of type t will be available after some time. QFuture, because it was designed to work on collections and it can collect multiple results, it's essentially a future of a list of t's. So each QFuture of t can give you hundreds, thousands of results, not just one. Okay, it can store an exception. If there is a problem in the asynchronous computation, it can return it just by defining an exception inside of the QFuture. Unfortunately, again, the API is a little bit limiting, so the only way that you can actually check whether the computation was okay or not is by calling .get, and the .get will throw that exception again if the error occurred. And we have a job control like pausing the future, canceling the future, and stuff like that, which is, again, not really a part of future, but for Qt, it kind of is. So because we saw that the API is a little bit rudimentary, we want to dig a little bit lower, in the lower levels, to see how the QFuture is implemented. The QFuture class itself is a really, really tiny thing. The most of the implementation is in the QFuture interface, which is a private Qt class. It is private, but it needs to be both API and ABI stable because of Qt policies. So even if it's private, we can kind of use it and hack things with it. The idea is you create a QFuture interface instance, and it should have a member function called future, and it should return the QFuture. So a few examples. If you wanted to create a QFuture that already contains a value, you can do it simply by creating an instance of QFuture interface of t, and say this future has started, the job has started, we got a value, the job has ended. This will create a future that already has a given value. So maybe a useless future because it's not really asynchronous. It does immediately return you a value. But if you want to compose a lot of futures in your programs, then this can be quite useful. The next useful future is the canceled one. Just like the default one, just we want to define exception that will occur. Again, you just create a QFuture interface instance, say the job has started, we got an exception, the job has ended. And now we have created a future that contains an error. Again, it's really useful when communicating with your client, the code that is using your library, that something in a synchronous process, something has gone wrong. Now, both of these examples were synchronous futures, so you get the value or the error immediately. We can create something a little bit more complex. We can create a future that will return a value after a few seconds. Now, this can be used as a debouncing mechanism when user types something and you want to wait a couple of seconds after the last key press. So you can have a delayed future interface. You need to, because we want to listen to a timer, we need to inherit the Q object, and we have to inherit QFuture interface to be able to return a future instance. What would the implementation look like? We would create a start member function inside of our class, and essentially it would do the same thing that we already had. Report started, and when the timer hits a specified number of milliseconds, you just report the result and report that the future has ended. And now we actually have an asynchronous future, a future that will arrive after a predefined number of milliseconds. So asynchronous. Now, when I was playing and digging through the QFuture implementation, I started working on a small, really unstable, and probably will never really be released library called async.Qt, which was with the idea to make futures great again. Okay. So the things that we saw in the previous slides, I decided to create a little bit of a library so that we can wrap a lot of things inside of a future. So the things that we already seen, there is a function called makeReadyFuture, which makes a future that is already ready. Make a canceled future and make a delayed future. And you can just compose them as any other futures. But again, we don't need to stop at simple things like those. We can create a wrapper around all the dbus calls, around when you want to execute a process and you want to get a result. You, again, don't want to block your program until the result appears. You want to have a future of some process that you execute. So for example, process : get output of ls, list all the files in the directory. When the command finishes, you'll get the value inside your future. And again, process.exec, blah, blah, blah. So the next thing is, how do I get the value? Because we have now seen how to create QFuture wrappers around almost anything. Just start the job, report the result, end the job. How do we get the value? Again, we said we shouldn't use .get. Now, in this case, using .get is even more dangerous than on a normal QFuture. Can anybody tell me why? For example, you created a future from a dbus call or output of a command. If you call a .get, what will happen? It will block for how much? Forever. Because what happens? You live in a single thread, and then you block your current thread until the command finishes, and the command will never be able to report that it has finished to you because you have blocked your only thread. So .get in the futures that are returned by the async.Qt library is implemented in a way to crash your program, which is freaking awesome, because it's like dereferencing an invalid pointer, right? If you try to access the value of something and that thing doesn't contain a value, it should be a segfault. It shouldn't block your program. So by accident, the futures from async.Qt library crash your program and then force you to actually implement your code in the right non-blocking way. So, okay, because .get is evil, we would like to have something like .den in the QFuture. Unfortunately, the Qt maintainers are not really that happy about extending QFuture, so some patches left unnoticed and unmerged. So we can't really create a .den. But we can do an evil thing like Eric Nibbler did with ranges. We can, instead of .den, we can use a bar operator to define a .den-like function. So what we can do is just say input, bar, and a lambda. What will it do? When input gets a value, it will call the lambda that's defined after the bar. The lambda will be executed, and the result of the whole expression will be the future of the result of that lambda. Is it okay? So in essence, you have a future of one type, then bar it through a lambda, and you get a future as a result of the whole operation. You get a future of the result that will be returned by that lambda inside. So then you can chain. You can continue just bar, 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 and then get the last value as the result of your future, which is kind of cool. So what we can do, we can define again functions, transformation functions like in Boost Range or Eric Nibbler's Range v3 library. You can say input bar transform, which will get the item in a future that's contained in a future. apply a function to it, and again, return the result as a future. Then you can define bar filter, and you have a really similar syntax to all the range libraries. What will filter do? Because we said a QFuture can have multiple values, it will in the end give you a future of the values that satisfy some predicate. So just imagine the user gives you 1,000 of lines of text, and you need to validate them, and you don't want your program to block. You just say input bar filter the valid lines, and the result will ignore all the invalid lines, and you'll get a future with just the valid ones. Now we can create a cast operator, because when you execute a program, you're going to get a Q byte string, and nobody likes Q byte string. We all like Q strings, byte array. And we can create a cast operator that's future bar cast to some other type. Again, when the future arrives, when the value in the future arrives, it will be cast to a different type, and then you'll get a future of a different type. Okay, I can skip this one. And obviously, because fork join patterns are still useful, but Qt doesn't really provide that much in terms of composing futures. You should also have functions like collect. You have a list of futures, and it will give you a future of a list or any other collection. Or a tuple of futures, you're going to get a future of the tuple and stuff and similar stuff. So, again, this kind of fixes some of the QFuture problems, and you can do a lot with QFuture if you need to, but still, there are problems. You can either have single values inside of a future or a collection. You can't model data streams. For example, when you move a mouse, each of the mouse movements is a value that appears sometime in the future, right? So it would be really nice if we could use QFuture to model all those mouse streams and then transform them, filter them, and stuff like that. Unfortunately, the problem with QFuture is that it will remember all the previous values. So you can't use it for streams because you will just eat up your whole memory. The second problem is that the custom our QFutures are not really supported by Qt. In that sense, that's the reason why .get crashes and everything else, which for me is a good thing, but some of the things that should work with QFutures might have not worked with your custom implementations. And if Qt 6 decides to destroy the QFuture completely and revamp it, you would need to re-implement all of your code for that new infrastructure. As I said, during the Qt 5 lifetime, all of this code needs to continue working, not because it's officially supported by Qt or Qt guys, but because Qt cannot break ABI compatibility and API. And we are leveraging that fact. So in essence, async is a library that I'm using for a few projects, but not because I find it really, really useful. The only reason why I need it is that I need to use QFutures, because it's supported, the QFuture itself is supported by Qt. Okay, now we are switching to something really evil. And after this slide, don't ever write code that you'll see. The first part is we said that the API of QFuture doesn't allow you to get the exception that is contained inside unless you call .get, which will rethrow it. Throwing an exception is not a free process. It takes time, it takes everything. So it would be much nicer if we had a member function that said is an error or something like that. Unfortunately, the API of QFuture doesn't have it, and the patch for it was rejected at some point. So again, we want to dig a little bit into the QFuture. Who is familiar with the pimple idiom? Okay, who is not? So most of the classes in Qt are implemented with a pimple idiom, which is essentially, now I'm going to be like a professor. Because Qt needs to maintain binary compatibility. So every class in Qt needs to have a fixed size from the first release of Qt 5.0 to the last release of 5 point something. And if you had a class, and that class had a few members inside, and then you realize, okay, I need another member, you add another member, and the class grows, which is ABI break. Again, if you define a new virtual function, you're breaking your ABI. And a lot of stuff break the ABI. So the Qt guys use a really nice pattern that usually it's called Pimple, private implementation, short. In Qt, it's usually called a D pointer because they name it D for some reason. So instead of having a huge class, you just have a pointer to a private implementation class. So this is a class A. This will be a class A private. Now, this one is exposed in the library. This one is not. At least, obviously, the program can use it, but it's not in the public API. You can't use it directly, etc., etc. So when you change the private one, you haven't changed the public interface. The public interface class is still just one pointer. Now, usually, in Qt, all of these classes are actually A private. In the QFuture, because it's a really strange implementation, the D pointer is actually an instance of the QFuture interface that we saw earlier. And now, how we can access the private thing inside of a QFuture? Does anybody know how to access private member functions and members in a class? And not by define public, private public, which is the usual thing that everybody proposes. Before including a library, just define and then everything becomes public. QFuture is a templated class. So it means that you can instantiate that template and implement a function from that specialization. And in that thing, every private thing in the original class is accessible to you, because you're pretending that you're still in the QFuture. So we want to access the result store, exception store, and a couple of member functions that are private. How can we do it? We can declare some custom class that is just a dummy name of a class. It just doesn't really define a class, just declare it. Class QFuture hack has exception. And then we just create a specialization of, for example, is cancelled because it returns bool. And we want to get whether something has an exception. So again, it's a true or false. We can create a specialization of QFuture just for this hack type, dummy type, is cancelled. And what it can return the .exception store has exception. Now this is completely valid C++ code. It doesn't have any undefined behaviors or anything else. It's valid according to the standard. How can we use it? We can create a non-member function that's called hasException that works for a QFuture of T. And we can do a little bit of evil things. Reinterpret cast of that future to our custom one. And then call is cancelled on it. What does this do? Again, valid C++. We are certain that both of these classes are completely the same, binary and everything else, so we can do the reinterpret cast without any problems. And then we can access the is cancelled. Where is cancelled defined for QFuture of QFuture hack has exception in the line above. So instead of calling the default implementation for is cancelled on a QFuture, it will call ours. So we kind of injected our own code just to be able to access the private parts of the QFuture. Okay? Everybody fine with this? Okay. And now we can start working a little bit more. So we said that we can't really have a proper model for streams, for reactive streams or asynchronous streams inside of a QFuture. We would need to forget the previously collected values. Again, if we can access the private parts of a QFuture, we can do the same things for that one. So we can abuse the cancel member function to just clear the store. Unfortunately, in this case, it's not only the things in the QFuture that we are accessing that are private, but also the things inside of a QFuture interface are private. For example, the result store is private inside of a future interface. So not even QFuture can access it. Again, we can write another hack function and just for that one. And we can call it clear result store, and it would work in the same way as the previous one. Okay? Now, this thing has been actually tested, and it works with the latest Qt and everything else. This thing was too evil for me ever to actually include it in the real-world code. So I'm not sure whether this will crash the QFuture or not if you try to force it to forget all the values. But from what I've seen inside of the code of QFuture, this should also work. Because you just say clear the cache, and it just behaves like a new normal future that doesn't have a value in it. Okay, this is the end. I want to thank a couple of people. Zoltan, one of the great C++ guys from Budapest, and my professor, Sasha. I also want to thank, obviously, my friends at KD and Blue Systems, and Spasiba Yandex for bringing me to Nizhny Novgorod, or Nizhny. And that's it. One of the last thing, unfortunately, for the meeting C++, I got a couple of vouchers for free copies of my future book, which is still not really written, but it's in something that they call early access program. Unfortunately, for this thing, they gave me no vouchers. They just said, here, you have a discount code. And the sad part is that it's also called Meeting C++ discount code instead of C++ Russia. But that's unfortunately so. For this time, I don't really have freebies to give away, which is really sad. Okay, questions? Okay. Mike.
Thank you for a talk. I wonder why in 2016 Qt again tries to re-implement standard features. Wouldn't it be better to take part in concurrency work group and try to improve STD future?
That's a really great question. Unfortunately, I'll try to remain politically correct and not really answer what I want to. Historically, okay, Qt was initially started before STL implementations existed, blah, 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 so it had to copy everything. Fortunately, some of the Qt maintainers started deprecating stuff like algorithms in favor of the STD ones. And that's the only thing that I'm going to say. Why don't they are involved in a couple of standardization thingies, like the graphics one, and a couple more, I can't remember. But a couple of people, usually the OpenGL guys from KDAB who work on Qt 3D, they are actively involved in the graphic standardization. Unfortunately, I think that the whole Qt concurrent and QFuture just has never really been used by people, so nobody cares about it. Which is really the sad thing about it all. I would rather, so Mark was proposing either to move the QFuture to Qt Core or to rename it to be Qt concurrent colon future. That would be a much better choice because you could just ignore Qt concurrent and switch to the standard is.
Thank you for your answer.
And one addition, C++ libraries don't always guarantee ABI compatibility. So that's, again, one of the reasons why Qt people might copy everything from either standard or from Java library.
I have a question here. It's regarding your hack, how to access private members of a templated class. How is it intended to work if there are any other specialization for any other specific type?
Can you repeat because I didn't really catch?
Could you please show your slide with that hack? You do reinterpret cast on the reference you got inside. What if there are other specialization of QFuture of any specific type you have a reference in, and you casting those reference to reference of Q interface with your type, but is never related to T?
Essentially, this type doesn't exist, right? So
it might exist in the Q INA or whatever, or any other specialization. Or any other hacker does the same thing you do and pass reference to what type to your function.
Well, my type that is just local in a file cannot exist in other parts of Qt.
Yep.
So
you have a template function what does accept QFuture T. The T is that template parameter. You can get QFuture of T of any type.
Okay, you meant that. You meant somebody can implement has exception to use.
Somebody can do the same thing you do and pass the reference to QFuture, but inside your function.
Why not?
And in this case, hacks implemented outside of your library and those functions will never be called from inside the function, and you actually does the break code of something, of someone.
If somebody is really evil, then it will break. But you have actually to be, you need to be malicious to override the override in the same way that the hack override.
I do understand the hack, but I'm trying to say that this code is not actually quite standard conforming, because you do a cast inside.
It is standard conformant. You can check out Scott Marcy's. He had one of the got W's exactly talking about how to access private members. Okay. And essentially he called this the legalese approach, because you're using the bugs inside of the standard to achieve something, to be valid C++.
The problem is not the hack with the template class. The problem is with the cast.
It's not a problem because if this class doesn't exist, so if you tried actually to cast to something and use it afterwards, it would be a compilation error.
It might be correct if inside your hack you could have you would have a second template parameter of the original type you get the reference to.
Yes, if you actually needed to access the type. Here we don't.
You have to, because it's already existing code.
So
okay,
again, to reiterate, when you're casting to something, the problem with reinterpret cast is when you cast one type to another and use it. Incompatible type. Here, no casting actually occurs. So this type the T will never be used as a class QFuture has exception. So it's not invalid. It can't be used as it because the type is not implemented. If you tried to actually cast and use the result of the cast, you will get a compilation error because the class doesn't exist. Okay?
Thanks for the talk. As far as I can tell, futures or promises, the only one side of, I think, programming. Many languages adopt that. The most noticeable is JavaScript, maybe. Another approach is basically coroutines, which are implemented in some languages. I wonder if there are any chance to use something like that in C++ and Qt particularly.
Okay, depending on which types of coroutines you mean. So one of the things that is proposed for some of the future standards and it should, okay, the await thing will be the coroutines for C++. Essentially, what it means when you reach the await, just abandon the current function, and just remember that you need to continue it at some point. So a coroutine enters out when the next await appears again. We exit out and we continue with the coroutines. Now, all the things, futures and stuff like that, are really natural to be used with coroutines. For example, in this case, if you actually get the co-await inside the standard, we'll be able to implement await for QFuture, await for STD_Future, await for any other type of future or anything else that you want. And then you will be able to use coroutines with futures. Now, one way is to use all these things via coroutines to make the code pretty. The other approach is to use the functional transformations with the bars, bars, bars. And both of them have benefits and obviously downsides. So this thing is really natural to be used with coroutines, just depending on the coroutine implementation, how hard it is to actually force the QFuture to be a coroutine compatible.
Thanks.
Hello. I have. I think I have some dummy question. Why ABI compatibility is so important for you, for us, and why it's so?
Essentially, if you ship your software to somebody, and for example, you have Yandex Maps or something like that, and you use Qt, and somebody just upgrades Qt to a newer version, your code would break if it's not ABI compatible.
And what?
And your program doesn't work.
Why?
Because when it starts when the operating system tries to run it, it will try to link, usually unless you're on Windows and you have a local packaged Qt, to the system version of Qt, which might be incompatible.
Oh, it's when we use non-disk operation system. For example, non-hardware operation system in the memory, only in the memory.
I didn't get you.
Okay, thanks.
In essence, just imagine you learned Russian 100, 200, 500 years ago, and then you just appear in Moscow today. You're not going to be really compatible with those people, right? Because the language changed, and in the same way, the interface to the library has changed, and you're trying to communicate with it, to link to the library, and you get a crash because you can't link to something that you think this is the language that it speaks, and it just doesn't respond. Okay.
So, I actually have a question. First of all, thanks for the talk. And some naughty stuff you've shown us. I think it's pretty dangerous. And the question is, it might be easier to maintain a patch for Qt sources and build your own Qt than do this really naughty and evil stuff. And it's if QFuture is not that common in Qt, that it means that patch will be easily applied and on every Qt source update.
Yes, I do agree. Although I would go one step further, implement your own library with your own features. The reason why this approach is not really acceptable, the one that you proposed for KDE, is that we try to use system libraries, and we usually can convince Linux distributions to apply some patches that we need, but only if we have a promise that it will be included in the future versions of Qt. We don't want to ship a separate Qt library compiled, Qt library _ my own, just for our programs to work. The problem with that approach is just like when you're on Windows and you ship the whole Qt library with your software, because it never gets updated, security fixes remain and everything else. And if you don't update your library, then you're screwed.
Yeah, but as I said, QFuture is not going to update, as you mentioned.
No, I didn't mean that. For example, you create a fork of Qt with a normal QFuture. You compile it, you ship it to the client. It will never get automatically updated when Qt guys fix the bugs, unless you realize, okay, Qt guys had fixed the bugs, okay, reapply my patch, recompile, resend. So in essence, the only reason why all the QFuture thing exists and this talk with it is that I wanted to use just Qt I wanted to have my API just Qt based, and I didn't have anything else apart from QFuture to do it. Okay.
The next question. The main advantage of binary compatibility is the case when you can't recompile the whole program from scratch, or either you have no control of either plugins or whatever part. But in the case of KDE, I believe you can do the recompile from scratch with any new revision of KDE. So, being with true, isn't it simpler to have some kinds of some portions of Qt library or whatever to be a header only, and you in this case the old stuff what you do not need anymore simply got rid of the product by simply recompiling.
I agree. In essence, it's really strange that most of you are focusing on the parts that are red and don't ever do it, but I guess it's the most interesting part because it's a hack, right? I agree, it would be easy for KDE to recompile our own Qt, but there are a couple of reasons against it. We don't want to maintain our own fork. We want our KDE frameworks as of Qt 5 and KDE Frameworks 5 are add-on libraries for Qt so that anybody can use them. So it's not anymore just they need to be used in KDE software. But for example, there is K-Archive, it's used in a couple of companies that I know of and stuff like that. So we need to work with the default Qt, unfortunately.
So, and there is no way to make Qt guys do that decision for at least new features or partial features?
Well, I did try, and how many use cases I presented, they said, I don't see a use case there. So, I don't know, maybe somebody with more will than I have might push it, but I really don't have the time. I have too many things on my plate to actually be active in contributing to Qt and convincing them that this is a good idea.
By the way, are there any plans in Qt you are aware of for removing the old stuff that isn't really used anymore?
Essentially, I think the Qt 6 was the work on Qt 6 was announced, and it might remove some things. In Qt 5, we already had really nice STL classes, and they kept everything inside Qt 5 because of the almost API compatibility with Qt 4. They did destroy a couple of things, including everything that was QML based. But for the old stuff, QWidgets, QNetwork, QXML, and Qt collections, they tried to remain as back compatible as possible. And I think that's the main issue with C++ itself. The most ugly parts of C++ are compatibility with C, and then with old C++. And that's the same with Qt, unfortunately.
Okay.
Okay, thank you for your talk. And I think if there's any questions left, we'll better move it to the break. Thank you for coming.
Thanks.